Hello and welcome to another video. This time we're going to be looking at adding an analog output to our Agon computer, and we're going to be using a module based on the MCP4725 chip. The pins on the module are pretty easy to understand. We have the four i2c connections, that's ground, voltage, SDA and SCL. There's also an output pin where we'll get our analog voltage, as well as an extra ground pin next to it. This module comes with one fixed i2c bus address, but you can modify it by one by using the solder pads on the board. The configuration for sending data to this chip is pretty simple. In fact, it's one of the simplest ones we're going to look at in this series. What we're going to do is just go through a loop, increasing the voltage output. If we look at our code, we will start with the usual things at the beginning to set up a display, hide the cursor and open the I2c port. One of the first things we're going to do is actually reset a counter. D is going to be a counter for the analog value we're going to send to the output pin. At the beginning, we're going to go into a loop and check whether we've pressed the escape key for exiting. We will increase the counter by 1. And then we'll call a routine to actually set that analog value, followed by a short pause. We'll then check whether we've reached 255. If we have, we'll drop into another loop where we'll simply wait until the user presses another button to restart the counter. So how do we set the analog value? We send 3 bytes. The first is the command to say we want to set a value. Although this module has a resolution of 12 bits for its analog output, we'll only be using the upper 8 bits of that in this demonstration. So the second value byte we're going to send, we'll just put 0 into it for now. We then send the values out the I2c bus, and so that we can see what's going on, we'll print the value to the screen. Here I've hooked up my simple multimeter onto a voltage input, so that we can see what's being sent out. At the moment, it's virtually 0. If we load and run the code, we can see that we're counting through that loop fairly quickly on the most significant byte. As that byte rises, the voltage output rises, and we can see that measured. Now the maximum voltage we're going to get is the 3.3 volts that we have out from our Agon. So here a maximum value of 3.24 is pretty close, and remember we're only putting 0 into the least significant byte that we send out. If I hit enter, then we can start the loop again. So if your Agon project needs an analog voltage output, this type of module might be useful for you.